So the last part of the course will be about performance metrics, because we provide all these performance to you. What do they mean? Accuracy, F1 score, and AUC are the three major performance metrics. Well, accuracy is something that everybody can easily understand. How many, let's say you make 100 predictions. How many of those predictions are correct? But accuracy usually, as often, doesn't cover the whole picture. Example would be predicting, as I said, whether the spider is going to go up, right? In the bull market in the last 10 years, if your naive prediction is always that the market is going to go up, well, you're going to get 66% accuracy. Because in a bull market, 66% of sample are up and 33% are down. So if you just by default saying that, it's going to go up, the market, you won't be too wrong. But that's hardly machine learning, right? That's like a Robinhood trader prediction. So in an imbalanced class situation, that is, if you have much more positive sample than negative sample, accuracy doesn't tell the whole story. Similarly, what you need to do is to look at the other two numbers called precision and recall. Precision means if I predict the market is up, how many of those predictions are actually correct? So look at the denominator. The denominator only looking at the time when you're predicting one, not all the time. But again, the precision in the case if you are a Robinhood trader won't work, because the Robinhood trader is going to say it's going to go up, right? So again, you're going to get 66% precision, just like accuracy. You're going to get 66% precision. It doesn't make any difference. But then we have to look at the recall. Now, recall is going to hurt. It's going to really tell you whether your system is going to make that your system actually is predicted. Because in the denominator for the recall, we are looking at the actual days that the market went up, not whether you predict it's going to go up, because a Robinhood trader will always predict it's going to go up. So here we have a label, which is when the market actually went up. We are only focusing on 66% of that sample. And we will ask how many of those days we are actually going to go up, and the chances are that is going to be much lower than 100%, right? Because even though 66% of the days were up days, and you might get 66% accuracy if you just always predict up, but if you only focus on those days where the market is actually up, that is incorrect. The recall is actually going to be 100% if you're making a 100% prediction. Okay, that's going to be 100%. So I should backtrack. So for the Robinhood trader, where you're always predicting up, the recall is going to be 100%. It's going to be capture all the updates, and the precision might be 66%. So it's still pretty good, right? So an accuracy is 66%, because 66% of days is going to be up. So all of these metrics, whether you're measuring recall, precision, or accuracy, all will look fabulous for the Robinhood prediction. But the F1 score, which is the harmonic mean of precision recall, also will be good, because the underlying numbers are good. One is 100%, the other is 66%. So both of them are going to be good. So none of these features actually, none of these performance metrics is only going to tell you how your system is superior to a Robinhood trader. So as you can see, none of these will capture the problem when you have an imbalanced data set, such as the spider return. Okay, they're all going to indicate fabulous performance, 66%, because of the raging bull market. So what are we going to do about it? Okay, the final metric is going to tell the difference. This is called the ROC curve. It will plot the recall versus the false positive at different probability threshold. If So there are, both the accuracy and the recall and the precision are all based on a 50% threshold. If your probability is greater than 3%, it's going to call it a winning trade. Otherwise, it's a losing trade. But the ROC curve plot that as a function of the probability threshold, and that tells you a much more complete picture of your classifier, whether it's good or not. A good classifier will give you an ROC curve plotting the positive rate or recall as a function of the threshold, as a function of threshold. So for Robinhood traders, because they just always, they are not allowed to always predict. One, because you cannot only use a point estimate of always predicting one. It has to use a prediction based on probability, and a Robinhood trader cannot use a probability because they don't have a probability. They always just say it's 100%, right? So for a classifier, it does have a probability that it generates, and you have to plot this and force you to look at the probability at different rate, at different threshold, and it gives you a picture which is manifested in this ROC curve to decide if this ROC curve is concave. It indicates that the prediction makes sense. If the ROC curve is convex, below the curve, it will tell you that the classifier doesn't work. Okay, but a classifier that is consistently doesn't work is actually works because you can reverse the signal. Okay, so that's something to consider. But the worst classifier is when it is actually a straight line, because at a straight line, it means that it is just a random coin toss at any time. It doesn't tell you that you're right, and it doesn't tell you that it's wrong. So it's a coin toss. It's the worst classifier. If you have a classifier that is a convex curve, you just need to reverse that classifier. But before you do that, you have to question, how is it possible that this classifier always make the wrong decision, right? That's also an alarm bell. So I don't recommend actually that you reverse the prediction of a classifier. Instead, it should prompt you to look into errors in your system to see if there's any problem. You don't just foolishly, naively just flip the signal. Okay, so one question I have now is that when you use different index in the same model, you should have different performance. How does Hale deal with that? Supposing that you train the model on different index, let's say you mix up the data in the same model, Hale does not know that, right? We don't know exactly what the data is. This is a piece of software, right? It's a piece of software that is very easy to use, but it does not have the ability to know what the data is, right? So if you're going to mix up your data for different indices and stock, and it would naturally predict different, it will probably make a different accuracy prediction on different indices. You can't do anything about it because we don't know that you mix up the data. So what I would advise is that if you are going to, don't mix up the data. Build a different model for a different instrument or a different index. Now that, of course, might create a sparsity problem. You may not have enough data to build a model for different futures, but that is the only way that you can separate the performance on different index. And also, if you insist on building one model, it is okay for the performance to differ on different index, because that can be reviewed by your backtest. Remember, Hale only solved the part 2 of the problem. It doesn't solve the backtesting problem for you. There are many ways you can deal with the backtesting problem. You can use NinjaTrader, you can use TradeStation, you can use MATLAB, Python, whatever, if you are a programmer. Or you can even use Excel. If you're not a programmer, it's perfectly acceptable to use Excel for your backtest. So when it produces different kind of performance, and if you want to know if the system make different predictions for different indices, you have to analyze the outcome yourself. We have no possible way of knowing that you have mixed up data from different indices. let's look at the. So now, Herald doesn't actually output the entire ROC curve. It generates internally. What it outputs is what is called the area under the curve. So it takes the integral of that curve. If the integral is less than 0.5, that means the classifier is not good. If it's greater than 0.5, it's good. Okay, so that's AUC score is simply the area under the curve of the ROC curve. It gives you a summary statistic of whether your classifier performs well or not. And that is usually the performance that we look at. Greater than 0.5 or less than 0.5. Not accuracy, because that's easily biased by unequal sample population. Not F1 score, because that's still affected by the uneven sample population. But the AUC won't be affected by that because it looks at the entire ROC curve based on probability threshold. And that will that's the final summary number that you should look at, really.